And finally, we have the Internet, which is the globe-spanning IP network that links public resources such as websites, e-commerce applications, blogs, and more. Most important, it is home to the World Wide Web, a system of hypertext documents linked by the Universal Resource Locators and accessed through the Internet. It is based on the network developed by the US Department of Defense, called the Advanced Research Project Agency Networks. Let's talk now about the TCP/IP model, IPv4, IPv6, and the OSI model. The TCP/IP protocol suite has undergone several versions since it was first developed. The TCP/IP version that is most commonly used on the modern networks is the IPv4. The IPv6 is a new TCP/IP implementation that is increasing in prevalence as it addresses a number of shortcomings that have appeared in IPv4 over time. IPv4 was the first implementation of the Internet Protocol to be widely deployed, pretending to be the public Internet. It uses 32 bits, 4 bytes, or octets for addressing, thus providing a mathematical limit of 2 elevate at the 32 possible addresses. Some of the possible addresses are reserved, for example, for private networks or multi-cloud addresses, so that the maximum number of possible network addresses is somewhat less than the theoretical maximum. IPv4 addresses are commonly represented using what is called the dot decimal notation, in which the decimal value of each byte is shown using periods to separate the bytes. When IPv4 was first introduced, only the first octet was used for the network number, and the remaining 3 octets were used for the host number. This limited the number of possible networks to a maximum of 254, which was quickly seen to be inadequate. The next revision defined what is termed the classful addressing, in which the field for the network number was a different length for different classes of network, and the remaining bits were used for the host number, and each network class had a different maximum of number of nodes. Today, we use 4 classes of networks: class A, B, C, D, that is multicast, and E, that is for reserved addresses. Before we continue talking about IPv4 and TCP/IP, I would like to talk a little bit about the OSI model and the network layers. Initially, the OSI model was defined and designed by the International Organization for Standardization to provide a framework on which to build a suite of open system protocols. The vision was that this set of protocols would be used to develop an international network that would not be dependent on proprietary systems. Unfortunately, the speed at which the TCP/IP-based Internet was adopted and the rate at which it was expanded causes the OSI protocol suite development and acceptance to lag behind. Although few of the protocols developed using the OSI specifications are in, let's say, widespread use today, the 7-layer OSI model has made major contributions to the development of other protocols and products for all of type of the new networks. As a reference model, the OSI model provides an extensive list of functions and services that can occur at each layer. It also describes the interaction of each layer with the layers directly above and below it. There are 7 layers that conform the OSI model. The physical layer describes the mechanical, electrical, functional, and procedural means to activate, maintain, and deactivate physical connections for bit transmissions to and from network devices. The data link layer protocols describe the methods for exchanging data frames between devices over a common medium. The network layer provides services to exchange the individual pieces of data over the network between identified end devices. The transport layer defines the services to segment, transfer, and reassemble the data for individual communications between the end devices. The session layer provides services to the presentation layer, that is the next one, to organize its dialogue and manage data exchange. The presentation layers provides for common representations of the data transfer between the applications layer services. And finally, the application layer provides the means for end-to-end connectivity between individuals in the human network using data network. So in other words, for us to be a little bit easier to understand, the physical is timing and synchronization bits, the data link is destination and source physical addresses, the network is destination and source logical network addresses, the transport is destination and source processes number, that means ports, and the open layers is no more than the encoded application data. An IP address is an address used in order to uniquely identify a device on an IP network. This address, well, the IPv4 address, is made up of 32 binary bits, which can be divisible into a network portion and a host portion with the help of a subnet mask. The 32 bits are broken into 4 octets. One octet equals 8 bits. Each octet is converted to decimal and separated by a period or a dot. For this reason, an IP address is said to be expressed in a dot decimal format. The value in each octet range from 0 to 255 decimal, or from 0, 0, 0, 0, etc. to 1, 1, 1, 1, etc. binary. Here is how binary octets convert to decimal. The rightmost bit or less significant bit of an octet holds the value of 2 elevation 0. The bit just to the left of that holds the value of 2 elevated to the 1. This continues until the leftmost bit or most significant bit, which hold a value of 2 elevated to the 7. So if all of the binary bits are 1, the decimal equivalent will be 255. A great example of what I was explaining can be found in table 3.5 of the book. That, to be more exact, that is in page 89 of the book. Each IP address is made up of 2 parts, as I mentioned before: the network ID and the host ID. The network ID is used by routers to determine to which destination network a packet needs to be routed. The host ID is used by computers on the destination network to determine which packets are destined for them. The host and the network ID portions are determined through the use of a subnet or network mask. Class A, B, and C have default mask, also known as natural mask. Class A is 255, 0, 0, 0. Class B is 255, 255, 0, 0. And Class C is 255, 255, 255, 0.